Hello. In this video, we will show you how the dry fire contacts on our panels function and how to wire them for field devices. We'll cover wiring examples for shunt trip breakers, contactors, and troubleshooting components in the control circuit. Let's take a look. The panel has a set of dry fire contacts. These contacts are dry relay contacts and have no voltage or power from the factory. They are best described as a switch that our board controls in fire operation. Dry fire contacts are typically used for shunt trip breakers or contactors in order to kill power to the appliances underneath the hood. The contacts are rated for 8 amps and 250 volts AC. The dry fire contacts are connected to a relay on the main board. The contacts are factory wired to the relay common, normally open, and normally closed set of contacts. We energize the relay so that the actual dry fire contact terminals reflect that with power and not in fire, terminal C1 is common, terminal NO1 is normally open, and terminal NC1 is normally closed. If the panel was configured for 2 sets of dry fire contacts, the panel will have a second set, C2, NO2, and NC2. Do not use these contacts for providing signals to the building fire alarm panel, as they will also switch state if power is ever lost to the control panel. Use a spare fire suppression microswitch instead for signaling the building alarm. For wiring in a single shunt trip breaker, typically shunt coils require power to then trip or shunt the breaker. For this, we would need a power source that matches the coil's needs, typically 120 volts AC. And then we can wire up the coil just like a light bulb off a light switch. In this analogy, the control panel dry fire contacts are the switch. The coil voltage will come into C1, or the common of the dry fire contacts, and the normally open NO1 becomes our switch leg and will wire to the coil of the shunt trip breaker. To complete the circuit, the neutral of the power source also ties to the coil of the shunt trip breaker. If there are multiple shunt trip breakers, then they will wire in parallel. For wiring in a single contactor, typically contactors require power to be cut to then kill the appliance. For this, we would need a power source that matches the contactor coil voltage needs. It is suggested to use a typical 120 volt AC coil contactor. Then, we can wire up the contactor coil just like a light bulb off a light switch. In this analogy, the control panel dry fire contacts are a switch. The coil voltage will come into C1, or the common of the dry fire contacts. Then the normally closed NC1 becomes our switch leg and will wire to the coil of the contactor. To complete the circuit, the neutral of the power source also ties to the coil of the contactor. If there are multiple contactors, they will then wire in parallel. The best way to test the dry fire contacts is to troubleshoot the relay on the board. To troubleshoot the contacts with power to the board, nothing external wired to the dry fire contacts, and with the panel not in a fire fault, the contacts should have C1 and NC1 closed or connected. C1 and NO1 should be open or not connected. You could test this with a voltmeter set on the continuity setting. Now, with power off to the board, and with nothing external wired to the dry fire contacts, with the panel not in a fire fault, the contacts should have C1 and NO1 closed or connected, and C1 and NC1 should be open or not connected. If the contacts do not match this, please contact tech support and have the serial number of your control panel for reference. This relay is rated for 8 amps and up to 250 volts AC. Do not bring outlet or appliance power straight through the contacts. Do not wire both coil voltage hot and neutral to the contacts, as this will short the relay. Alternatives to the dry fire contacts are a fire suppression microswitch. This would need to be a free microswitch. The wiring logic of the dry fire contacts is the same for the microswitch. A fire suppression microswitch has a common, normally open, and normally closed terminal. As shown here, the wiring is the same for a microswitch as the dry fire contacts. Examples for shunt trip breakers and contactor coils are shown here for convenience. Thanks for watching this video. For more answers to your questions or any help, please contact tech support.